it's a single characteristic feature of life, in my opinion, there would have to be change. That biology is in part defined by change and constant sequences of changes in shape, in form, and in activity. And for those changes to be meaningful, to be evolutionarily valuable, those changes have to be controlled. And so we can, whenever we see change, we believe that there are actually two components in the process. There is some form of input information, some form of a signal that says change, and then some capacity of the cell or the organization to measure, to respond to that signal in a way that produces a meaningful, desired output. Now, we can think about that phenomena as these inputs and outputs that govern transitions and changes. We can think of them as very often signals and responses to signals. And if we're very brave, and often we do this, we talk about them as cause and effect. What causes cancer? What causes development? What are the effects? One of the ideas, the central ideas behind the talk that I'm going to give today, though, is to try to take this general biological view and try to make it more quantitative, try to bring the view of our understanding of input and output into a sense of what is the information content in the signal, in the input, and how much of that information is retained in the output, and molecularly, how is it that input information is converted quantitatively and mechanistically into a reproducible output. Now, the particular system that I have worked on for most of my life is the early Drosophila embryo. And for Drosophila, for many embryos, over the past 30 years, we've learned quite a bit about what the inputs and outputs are for very early decisions in embryos. We know, for example, that the final states of early individualized states of cells in an embryo, or this is in a cartoon embryo, can be traced back in the cells, in many embryos, to a distribution of molecules in the cytoplasm of the egg that are actually set up as molecules before the egg is even fertilized. So there's an input information that governs this decision. We know that very often this maternal cytoplasmic information forms a gradient, is formed by a gradient of transcription factors. And those transcription factors have the capacity of binding to enhancers or control regions of genes in a concentrated